All right, so today we're going to talk about aerodynamics. When we talk about aerodynamics, most people think about airplanes, things like that. Aerodynamics basically deals with airplanes, basically anything that moves through a fluid. And when we talk about a fluid, we're actually talking about gases and liquids. That's a very important thing to understand is we are dealing with multiple um, formats here. We can be, when we talk about aerodynamics, we're really talking about fluid dynamics. And when we talk about fluids, fluids are anything that have the ability to flow. So liquids and gases both have the ability to flow. So when we are talking about aerodynamics, we're talking about airplanes, we're talking about sports cars, we're talking about semi-trailer trucks going down the road, you running a submarine in the water, that type of thing. So we are talking about how materials flow around different objects and how that affects movement and things like that. So our lesson objectives for today are you will be able to understand the basic principles of aerodynamics. You'll have a general understanding of it. You'll be able to list the four basic forces of aerodynamics because anything we deal with there are always going to be four specific forces that have to be taken into account when we are dealing with aerodynamics or fluid dynamics. And then finally, you'll have a little bit of an understanding of what's going on in the world around you. I mean, there's a lot of things out there that truly deal with aerodynamics that we really don't think about on an everyday basis, I guess would be the best way to put it. All right. So, some fundamental principles of fluid dynamics. The first one is Bernoulli's principle, and we will talk about this in greater depth next week because next week is the Bernoulli principle presentation that I have planned. But Bernoulli's principle is just that fast moving air creates lower pressure. Same thing. And when I say air, we're talking about fluids too. Same thing can happen when you are dealing with water. The same things that can be used to cause flight in an airplane can also occur with water and allow things to kind of rise up in the water quite a bit as well. So there's some fluid dynamics there. With Bernoulli's principle, it explains why an airplane wing works, and it's because the air on top of the airplane wing is moving faster than the air below the airplane wing, which sounds weird because as an airplane flies across or through the air is moving and getting split on either side of it, of that wing. Well, because of the shape of the wing, the air has to travel a greater distance in the same amount of time over the top of the wing than the bottom of the wing. And if we think about speed, speed is distance divided by time. So if it has to follow a greater distance, then it's moving faster. And when air moves faster, that creates less pressure, and there's more pressure underneath the wing, causing the airplane to go up. Like I said, we'll get into a lot more detail with that. Conversely, when you look at, as it says here, race cars, they have the spoilers and things like that that are basically upside down airplane wings. And what that is doing is actually forcing the car down into the ground. Now, my question to you, real quick, would be why would forcing a race car to be tighter to the ground be important? Anyone want to give me an answer on that or think they know what's going on there? Anybody? Okay, I guess not. Let me go through the chat real quick and see if anybody's okay. Yeah, Brian's put out traction and to prevent lift, and lift is part of it. If you've ever seen those Formula One cars, every so often they'll be going fast enough if they catch an air underneath, they will flip over. And in a lot of cases, the biggest one is the traction. The more force that is pushed down on the car, the more friction it presents, which when you're dealing with friction in a car, yes, it's slowing you down, but it's also allowing for more force from the engine to the wheels to the ground to actually allow it to be able to run faster instead of spin out. And that's also great, not only for traction for causing the car to go faster, but also to keep it from sliding side to side as well. Yeah, and as Oscar put, yeah, it does same thing with NASCAR. You just see it a lot more with the Formula One because they are a little more aerodynamic and not quite as heavy as the NASCAR cars. And because of that, they can get up in the air. The F1, yeah, they can top most of the time they're running in that 250 range. NASCAR can top out on a straight line, yeah, like 250, but they're usually running on a track at about 175 to 200 miles an hour. Your 400, 500 mile an hour cars are your drag racers. And yeah, they have the same problems. They can flip over the same things, and that's all based on aerodynamics. I love the fact that you guys are kind of throwing these ideas out there because yes, you guys are seeing what we're talking about there, and that actually can happen some depending on wind shears and things like that on a normal car going down the highway. There are different places that air can get up underneath a car and cause some issues as well. Like I said, pressure differences, changes in air pressure. If there's more pressure in one area and less pressure in another, that's going to cause a push because remember when we talked about pressure, pressure is basically measured a force over an area. And the force is going to get bigger the bigger the area is. So that's why you have really big airplane wings. Finally, there's also what is called the Reynolds number. You're not going to need to know a lot about that, but I just thought it would be something neat for you guys to hear about a little bit. And that tells us when airflow becomes turbulent. And turbulence can cause some serious issues with, in particular, race cars. Um, that's why you see race cars racing almost nose to tailpipe in some cases. And because of turbulence there, if you pay real close attention to racing, I'm not a real racing aficionado by any stretch of the imagination, but I've heard it talked about and things like that. Um, you'll hear race car drivers sometimes talking about their back end getting squirrely and some things like that. Part of that is when another car gets right in behind them, it can cause some lift on the back end of the car in front by air turbulence. It causes the air to spin, and then that air gets up underneath the car in front, lifting. Well, it isn't lifting, but it is, but it isn't. It's causing less pressure on the ground, and therefore that car in front starts losing some traction, and that's what they're talking about when they start getting squirrely in the back end. Any questions so far? Because now I'm going to go into trying to ask you guys some questions and see what you guys think. All right. So our next thing here is I'm going to ask you what the four basic forces of aerodynamics are. Yes, Ryan, you have a question?
The answer to that is drag, gravity, lift, and thrust.
3 out of 4 ain't bad. Um, let's start with the one you missed, actually. The first one was where you said gravity, it's weight. And when we talk, and you are correct, gravity is causing that. Remember, what's the difference between weight and mass? What's the big difference between weight and mass? Anybody remember? Gravity. So when we deal with weight, mass is how much material is there. Weight is how much material is there times gravity. So with the gravity, yeah, it's similar, but the weight of a 747 versus the weight of a Lear jet is significantly different, right? But gravity is pulling on both of those in the same way. You just have to overcome a greater force with a 747 than you do with a Lear jet. That's part of the reason why we say weight instead of gravity. But yes, weight is very dependent upon gravity. So when they're talking about gravity, they are specifically talking about weight or the downward force. And then Ryan also said that the second one, lift is what is going to cause an airplane, a car, something to move upwards against the weight or the gravitational pull on the mass of that object. So what causes lift? Anybody want to throw any ideas out there on what would be causing lift? Yeah, Ryan.
Wouldn't it be how the wing is not shaped, or well, yes, shaped, but also the how the rudder, or not the rudder,
The
I
flap.
think the flaps are angled.
Yeah, the flaps angle kind of help with um, one, extending the distance of the top of the over the top of the wing, and two, they actually, when they kind of are forced down at an angle like this, what happens is the air coming underneath gets to pushing on those as well, and that can cause a greater pressure or greater force upward or downward as well. So flaps are important in helping with some of that. Yes, the wing shape is huge. The curvature of a wing is really, really huge. I'm going to grab this piece of paper here. If you guys want to try this at home, I suggest that as well. If I take this piece of paper, well, if I can get it to show up. Now this is too heavy. See if I can find a lighter piece of paper here on my desk real quick. If you take a piece of paper, and you get any not very stiff piece of paper, and you hold it, fingers on each side of the piece of paper. So pinch the front corners of the paper and have it kind of rolled up over the top. God, this is not showing up well on my computer screen, but notice how it's kind of curved here. When you blow on the top of that piece of paper, what happens to the piece of paper? It lifts up, and that is because the air moving over the top of the piece of paper is moving faster than the air underneath, which creates less pressure. Less pressure is less downward force. The pressure underneath is the air is moving slower, has more pressure, and causes it to move up. So that is what causes the lift that we are talking about there. So we had Ryan talk about flaps a little bit. How would adjusting the airplane from flying flat to pointing its nose up just a little bit, called the angle of attack, how would that affect lift on an airplane? Any ideas?
It's changing the surface area available for or air or more heavy air that go below the wing to lift up and create, or to generate lift, or yeah, to generate lift and bring the aircraft into the air.
Yeah, exactly. It's creating more when you tip that wing and get it up just a little bit. Now you're creating, as the air is coming in this case, you're not using Bernoulli's principle as much as just the plain fact that the air, and especially the faster you go, the air is going to push on that angle and force that airplane up, because here you're going to have a little bit of air pushing, and it's not a great amount of force because it has to do, like you said, with more area being able to be pushed on with more force. And by tipping it up, now we have a greater area that is exposed to that greater force, which causes more lift. That's a perfect example of that. Our next basic force is the force forward, right? And as Ryan called that, that's thrust. Okay. What causes thrust in an airplane? Yes, Oscar.
What about the hyperloop? Is that kind of as like aerodynamic because it has like a similar as a jet, like it can levitate from the tracks.
With a
But
what again?
well, the hyperloop is kind of like a pod. Oh, yeah, it's like a pod,
Uh-huh.
and it can float like a levitate.
I think that's more
Um,
magnetics.
yeah, some of that is magnetics, actually. They're using magnets to do that. But
Oh,
your
okay.
okay, but your thrust, I'm going to ask you a question. What causes thrust in an airplane?
Engine.
Exactly, an engine.
Yep. Yep.
Move
A engine.
engine and propeller, whatever happens to be causing the plane, car, train, whatever to move forward is what is causing the thrust. So it could be a jet engine, it can be a propellered engine, gas engine, that type of thing. So thrust becomes very important because the faster an object moves, the less pressure there is on above the wing or above it versus below it. And the faster and faster that goes, the more like the basically you're making the object what we what we would call in physics force normal. And force normal is just what's pushing down on the object, whether it be a plane, a car, a train, whatever. It has to do with the weight and the angle at which everything is at. But the faster and faster that moves, the less force normal or down into the ground that is, and that allows things to fly up. I'm sure I've seen it for almost my entire life. When I was a very young child, every Saturday there was a sports show called The Wide World of Sports, and you would watch that because there wasn't a lot else to watch when I was a kid back when the dinosaurs roamed the earth. But they had jet boats and things like that. And one of the scenes for the opening of the Wide World of Sports was a jet boat going, and all of a sudden you just see it launch and flip up and actually spin backwards over because of losing the thrust, having enough thrust and losing the force normal, holding it down, and the lift overcame the weight to the point that it caused it to tumble. And then finally, our last force is the drag. What causes drag?
Everything else.
Everything else.
True. Yep.
That's a great way to put it. Um, if if I told you you had to replace the word drag with one other word, what would you use?
Probably turbulence of some
Close.
sort.
It's caused by this word, and I'll give you a hint. The word starts with the letter F. Oscar, you have your hand up again, or
I think it's something with the F.
yeah.
I think I know it, but I forgot what it is.
If I were to tell you you're sliding into second base, what stops you? What stops you when you're sliding?
Oh, force. It's force.
Not force. It's a specific force. I'm really making you guys think. All right, I'm going to let you guys off the hook. It's friction. Friction. So drag is just another word for friction. And when they talk about drag, they're being very specific on their friction. They're talking about the fluid, whether it be air or water, liquid of some sort, moving along the side of the plane, because you get drag with submarines, things like that. There's a reason why submarines are shaped the way they are. Anyone want to hazard a guess why that is? Why they're shaped that way? And I'm going to tell you right now, it's an organism that they were that they're shaped like, that they were based on, their tubular shape was based on a very specific living organism. When you think of animals that move quickly through the water, what do you think of?
Eel.
Eel? Okay. I was thinking more salt water, and everybody goes to their shows. You can actually ride them if you're in Cancun, pay money and get to ride them. Riding.
Dolphins? I
There
don't
you
know.
go.
Oh,
Dolphins.
dolphin. Oh, okay.
Yeah, that you think about the shape of a submarine and the shape of a dolphin, they're eerily similar. That they're that same tubular shape, right? That's a big deal. So there's that. All right.
I do have a question.
Yeah.
How do these four basic forces of aerodynamics apply to helicopters?
Good question. That's a really, the reason I'm laughing is because um
They don't apply
so
this
it's just
to
something that I've
helicopters.
heard in the past. Airplanes and things like that fly because of the thrust and the movement of the um air around the wing, and that helicopters beat the air into submission. Well, basically, helicopters work very, those blades that are on top of the helicopter really and truly are shaped like small wings. Okay. So a helicopter, by spinning its rotor very, very rapidly, is creating a centripetal thrust. That, and what I mean by centripetal, it's a circular thrust that causes the wings, and again, the pressure above those rotors on the top of the airplane, of the top of the rotor versus the bottom of the rotor, causes the lift. So it's the same as an airplane. It's just, instead of moving in a straightforward direction to create that lift versus to beat the weight, now the helicopter itself is spinning the wings, and because the helicopter is spinning the wings, it can create enough force that it doesn't have to move forward for the lift to overcome the weight. Hope that makes a little bit of sense.
So it is just really beating the air into submission.
Yeah, it's really beating the air into submission. It's pushing, it's causing the air to move faster above the rotors than below. And because of that, there's a pressure change, and that causes the lift. So yeah, it's very much, it's creating the wind instead of going and creating the wind in a singular direction. You It's creating the wind by basically moving the wings, instead of the wings moving through the air, it's moving the wing, it's moving the air around the wings. And that's also part of the reason why, if you didn't know this, here's a piece of random information for everybody. And that is that when you deal with the Navy and you've seen aircraft carriers always turn into the wind when they are launching airplanes. Anyone have an idea why that might be?
Wind direction can affect the I believe the lift and the drag. Lift,
Yeah,
drag, or weight, one of those.
yeah, it's the lift more than the drag. Yeah, it will increase the drag. It will also increase the lift. Um, if a plane needs to have the air moving over its wing at 100 miles an hour to get enough lift to take off, that's why you have really long runways on the ground, or when it's on the surface of the earth. You run out of space on a aircraft carrier. So what they do a couple of things to help with that. they use what are called catapults to help the airplane be able to increase its speed at a much more rapid rate, so it reaches that point that it can take off much quicker. And it can even do that even better when it's turned into the wind, because the wind is already pushing across that airplane wing. It's kind of like when you see the wind come up and launch tents or things like that in the air. That is because the wind itself is creating the movement of the air versus the air being still and the plane moving through it. It's kind of a cheat code. All right. Now, real quick, go through the basic forces again, so that, and keep it pretty simple. Lift is just the upward force that counters weight. Drag is our air resistance that opposes motion, basically friction. Thrust is the forward movement that propels the object, whether it be a plane, car, whatever. And then, of course, weight is the gravitational force pulling down on something. And obviously that changes based on the amount of mass. All right. Like I said before, there are aerodynamics in nature. Nature has a perfect aerodynamic design through evolution. Dolphins were a big thing on how to build submarines, things like that. The wings of bugs, things of that nature, are what kind of helped with some of the things that we see that fly now. Instead of using, they tried originally with helicopters to create an up and down motion that would follow kind of the wings of how bugs and birds flap. Was not real good for us, but once we kind of decided, oh, if we move it in a circle, things would be a little bit better. And that's kind of what you see here with this plant.
Didn't aerodynamics or the traditional wing structure of an aircraft come from hummingbirds?
That is definitely a possibility. I can't say yes or no to that, but it's definitely a possibility, and I wouldn't argue with you on it. If you read that somewhere, I believe you.
I think I read. I think it's in the lessons somewhere that goes over this. I think it's somewhere in that, in
Yeah,
the string of lessons that is about that. So
I'm going to guess it's definitely from birds in general. Now, whether it's a specific hummingbird or not, I'm not going to argue that whatsoever with anybody. All right. I'm going to go ahead. We're running out of time. I'm going to go ahead and skip this video. But if you want to watch it, like I said, I put the link to this video, or the slide onto this. We're taking a little longer than I thought. It just kind of reiterates some of the stuff that I've been asking you about. Come on, go ahead. Skip forward. Why are you skipping forward for me? All right, we'll do this. I have a couple more slides that I want to get through real quick. So to talk about some other things a little more than what we've been doing. That video kind of goes through the same stuff that we've been talking about. Okay, we've kind of talked about some of these applications in transportation, like with motorsports, cars using spoilers and things like that to push down on the car so that they can get more traction, is a perfect example of that. Diffusers are just basically a smaller spoiler that are used to try to break up turbulence so that the car doesn't get, as they say, squirrely. Aviation, with airplanes, they're starting to put winglets, which help minimize vortices, and all vortices are, again, are that turbulence that we're talking about. Yes, Oscar.
I see the fur transport.
Yeah.
The
Okay. And
oh,
go
sorry.
ahead.
Oh, I think I will take the rail transport here. If we look here, the nose of the train, that's aerodynamics.
Yep.
And the train powered by the canary wires goes up. And it could make it go faster. It depends if just for example, if the Siemens build the Siemens chargers, especially the Brightway ones, they're they have a streamline. That means it could go push that have the less drag.
Right. And that's why they use magnets on those. Most people don't realize that, but these bullet trains is what they're called are driven by magnets. One, the magnets help force the train up off, so there's a heck of a lot less friction, which allows them to move faster. And then by turning on and off certain magnets along the rail, that's actually how they propel the train. It isn't the train using a true motor as much as it is changing magnetism. And well, it's the train changing the magnetism, not the rails itself. But that's what's going on, is there's a constant change of magnets that are causing that train to move down the track very rapidly. It's a repulsion type setup, and it's really neat how that works. These winglets that we're talking about are what we see right here, kind of underneath the wing, and then you'll see them when you look at big airplanes, that they're kind of tilt up and form one side of a U at the end of the wing. Those are all there to kind of help with vortices, which is again turbulence. And anytime you remove turbulence, you are increasing fuel efficiency. And then again, as Oscar was saying, high-speed trains use the streamlined noses and things like that because it helps cut down on the amount of energy needed. And everything is about trying to save energy because, one, we need to save our fuel sources that we have and be more efficient with what we have. And two, it's just plain cheaper. And that's the biggest reason with companies. It's more about cheaper than it is about saving our environment. But in this case, it's doing both. Okay, finally, the future of aerodynamic innovations. Like I said before, bio-inspired design, mimicking nature's solutions for efficiency. That has a lot to do with, in particular, submarines and dolphins are the best example that I can come up with for that. Sustainable materials, finding lighter composites reduces energy. Anytime we can find a way to make things lighter, most airplane wings now are not as much metal as they are fiberglass, just because it's lighter. And the less a plane weighs, the less lift that it has to produce, so it doesn't have to move quite as fast, things like that. We're starting to see it a lot. I live in Kansas. We're starting to see a lot of that there with turbines. We're using an awful lot of turbines in the state, using turbines in the state of Kansas to produce electricity now. And the shape of the wing on the turbines being more and more efficient with that helps us be able to produce more electricity quickly. And then finally, smart surfaces are structures that can change with conditions, so they can be adjusted so that maybe, well, in particular, back to the wind turbines, they can adjust the blades so that they don't get moving too fast, or they can get them to move faster by adjusting the angle and turning them into the wind, things of that nature. Are there any questions? Well,
I have a question for when everyone else is gone.
Okay. I'm going to go ahead and stop the share here real quick. Say goodbye to everybody. I'm going to stop the recording as well.